Welcome to the micro communication course. Today we see that a EHT, how to derive the S matrix for the EHT here. Now then, as you know that for the given particular magic T, so it has a, we say that a 4 port here. That 4 ports just I draw the magic T here again. And we supposed to be consider that for the given particular magic T, one is about your E arm here and one is about your H arm. Okay, so now this is about your H, this one is about E here. So I say that port 1, port 2, port 3, and a port 4. Now you remember always that E arm is to be port 3 and H arm is to be a port 4. Now we need to find out the matrix component for this magic T. So then what are the matrix component for the magic T? As we say earlier, that collinear arm port 1 and a port 2, if we are providing the input, so output will be equally divided in a E arm or H arm there. Okay, not equally. We say that if it is input at port 1 here, so it is a summation here, takes difference takes place here, and summation takes place at H arm. But if we consider that input at a port 3 here, output is equally divided in 1 and 2, no output at port 4. If we are providing the input at a port 4, output is equally divided in 1 and 2, no output at a port 3. Okay, that we say earlier. Now then, we say that here, the port, whatever the port we supposed to be considered that port 1, port 2, port 3, and port 4. All these ports are perfectly matched. Okay, all these ports are perfectly matched to the junction. Okay, this one we say that it is about a perfectly matched to the given junction. So in that case, we write S11 is equal to S22 is equal to S33 is equal to S42 is equal to 0 because these are all the ports are perfectly matched to the junction, then all the components will be at 0 here. Okay, so now then port 1 and port 2 we say port 1 and port 2 because if we are providing the input to the port 1, output is available at port 3 and port 4. No output is present at port 2. So similarly, if we are providing the input to the port 2, output will is available at port 3 and port 4. No output at a port 1. Means port 1 and a port 2 are perfectly isolated. Similarly, if we provide the input to the port 3, output is equally divided in port 1 and a port 2 but out of phase, but no output at a port 4. Again, if we consider that input at a port 4, output is equally divided in port 1 and a port 2, no output at a port 3, means we can say that here port 3 and a port 4 again perfectly isolated. So from this we say that a port 1 and a port 2, similarly we say that a port 3 and a port 4, all these ports we say that it is a perfectly isolated. Okay, now this one we say that port 1 and port 2 means we say that port 1 if we are providing the input to the port 1, no output at a port 2. If we are providing the input to the port 2, no output at a port 1 means it is perfectly isolated. Similarly, for a port 3, if we provide the input to the port 3, no output at a port 4. If we are providing the input to the port 4, no output at a port 3. Means that we say here it is about a perfectly isolated port now. So from this perfectly isolated, what are the conditions here? Isolation means what we can say here. We say that if we are providing the input to the port 1, no at a port 2, no output. Similarly, we say that input to the port 2, no output at port 1. Okay, let's say that 1 to 2 means if we say that input to the port 1, output at a port 2, that is 0. Okay, or we can say that input to the port 2, output at a port 1, it is again a 0. Or we can say that input to the port 3, output at a port 4 is equal to 0. Input to the port 4, output at a port 3 will be a 0. Means we say that S21, S12, S43, S34 both are equal to 0. Now with this condition, if we rewrite here, what we can say that S21 is equal to, okay, we can say that S12 is equal to S43 is equal to S34 is equal to 0. Okay, now this one is a condition here. We say, so from this, we can rewrite the S matrix again. Okay, so how to rewrite the matrix again? So this S11 term, okay, so we got that S11 term 0, S22 term again is 0. Okay, we got that S33 is again 0 because this one is about a perfectly matched. This equation. This equation is saying that S11, S22, S33 both are 0 because it is about a perfectly matched. This one is about a 0. This term is a 0. This term is a 0. This term is a 0. Next one. Here we say that S21 is equal to 0, S12 is equal to 0, S43 is equal to 0, S34 is equal to 0. This what? This one S34 and S43. These are about the terms. We're supposed to say that this one is 0, this term is 0. S12 and S21. These are again 0 here. Sorry. Now how your matrix looks like? This matrix looks like it has only this. Okay. These are the terms present in the S matrix of a matching T. Our aim is about to obtain the S13, S14 values. These are the values whichever the remaining components are there. We need to obtain the values of all these elements. Then how to obtain the values of all the elements? Then again we have to use the same condition that is symmetric property. Okay. So we consider that a symmetry property, unitary property, and then we obtain the all these component, all these parameters of the S matrix. Now I'll rewrite here. Okay, I'll rewrite the terms now. Just consider that I say that from symmetry property, from what property? That is about a symmetry property. That is about a symmetry property. Now from the symmetry property, what we say that S14 is equal to S41 is equal to S24 is equal to what? S42. Then S31 is equal to S13 is equal to minus S23 is equal to minus S32. S14 means 4 is the input, 1 is the output. 1 is input, 4 is output. 4 is input, 2 is output. 2 is input, 4 is output. Okay, means these are equal here. Okay, so that terms are equal here. From the symmetry property, from this, we say that S14 or S41, S24 or S42 are equal. So S13 or S31. Why it is a minus? Because it is anti-symmetrical one. That's why you can say that for the port 3 it is anti-symmetrical. So that's why it is a minus here. Okay, this term is a minus. Now we will see here how we will get the terms. Okay, from this, suppose if we rewrite the matrix again, the S13, S14 here, if suppose to we are writing, okay, but this term S23, okay, we can write S23 will be AS13. Okay, S23 will be AS13. From this S24, we say that S24 can be S14. Okay, so from this S24 can be S1. Then similarly, we can rewrite all the terms here. Okay, so from those properties, and can substitute all these. Again, one more condition is there. So we say that the condition of, okay, that S matrix here. Okay, so we supposed to be consider that the perfectly matched condition and that property. So we obtain the S matrix likewise. Now forget about those conditions. Now we can consider that all the components right now. Okay, I just consider again here. I rewrite all the terms now. S11, S12, S21, S22. Okay, S31, S32, S33, S34, S43, S alba. Okay, this is about S matrix. Now from the symmetry property, we say that these terms now. Then again, a perfectly matched condition. That is about the junction condition there. In that case, that port 3 junction, it is a perfectly matched, or a port 4 junction, it is a perfectly matched. In that case, our isolation take here, we say that S34 is equal to S43 is equal to 0. And then we say that S44 is equal to S33 is equal to 0. That is about it. Port 3 or the port 4 is perfectly matched. That is the condition. And what is the condition? Another thing is that port 3 and port 4 are perfectly isolated. Forget about that collinear arm. Collinear arm length is supposed to be a different one. So in that case, okay, in that case, port 1 and port 2 will not be isolated. Okay, so I just supposed to be considered now. Okay, isolation condition. So in that case, the 1 and 2 will not be isolated. Okay, if that arm length or arm size will not be the same there. So in that case, it will not be a perfect one to be considered that that particular arm is to be matched. But we can obtain that how that S11 and S12, okay, how that S21 and S22 that will be a perfectly matched, or how it will be a zero there. Okay, that will be obtained. So with this, from this, if you put that all these parameters in S matrix here, so you can matrix will be changed here. All these conditions, first row will be same as it is, but the second row will be changed S to 1, S to 2. Then this becomes a, this will be changes here. Okay, S to 3 instead of that, we'll write S13 here. Then we'll write that S1. Then this will be what? S13 and S14. So this will be what? S13. This is the minus S13. Then S14 and S1. Then all these terms we say that perfectly match and is isolated, perfectly isolated. For that, we're supposed to be find out that these are the zeros and this one is about is 0. Okay, so now we will consider that a property is here, all the properties, and we can obtain that what is the matrix. And as we mentioned that this port is a perfectly matched because port 1 and a port 2, if supposed to be collinear arm, it is to be perfectly matched. Then this term is again is 0 here. Okay, say that it is about a perfectly matched. Or even we can solve it through the equations and can say that this term will be perfectly matched and this one will be a 0 here. Okay, this way we can obtain that whatever the component of that S11 or we say that S12, it is to be a 0 there. Okay, this way also we can calculate that. So as we say earlier, it is to be perfectly matched, or I'll just go to derive it now. I'll just show you how it is to be obtained. 1 and now through this, use this equation. Now these are the S matrix using this condition. Now these are the equations here. We need to apply the properties, unitary property and a zero property, and then we'll conclude about those all these component of a S matrix. The way here we can use here first is about a unitary property. For this S matrix, whichever the obtained we can use a unitary property. What is the unitary property? We say that matrix S and complex conjugate of a matrix X is equal to identical matrix. Or you can say 1. Okay, likewise. So now that is about a unitary property. So this matrix, complex conjugate of this matrix is equal to 1 here. So that's about a matrix bracketing. So now from this, we can apply or that property multiplying, you can say that row 1 and a row 2. Okay. Similarly, we can consider that a component of a row 1 and a column 1, row 2 and a column 2. Likewise, we have to consider. Okay, so we say that here multiplying row 1 and a column 1, using that we'll get that S11 square plus S12 square plus S13 square plus S14 square is equal to 1. Then next we say that a row 2 and a column 2. Okay, row 2 and a column 2. So now in that case we will get that S12 square plus S22 square plus S13 square plus equal to 1. Now from these two equations, if we equate this equation here, okay, if we equate this equation and this equation here, these two equations here, so from these equations we will get that S11 minus, okay, but you can say that we just equate this equation here. This term S12 S12 cancel, S13 S13 cancel, S14 S14 cancel. Only we have that S11 at S22 top. S11 is equal to S22. Then we say that we have, or we can write here S11 is equal to S22. Simply. That is about here the condition. S11 is equal to S12, S22. Sorry, S11 is equal to S22 because this term is a common. All other terms are common, that will be cancelled. Only this term will be remaining. S11 is equal to S22. That's about a first term. Then from the row 3 and a column 3, okay, from the row 3 and column 3, just I am going to erase this one now. Okay, same property here. I'll just write that here again. What matrix, what values we have obtained here. So we got that S11 is equal to, that is one term. Then consider that a row 3 and a column 3. Okay, unitary property again. Applied unitary property again to the row 3 and column 3. This one, row 3 and column 3. Then we get that okay. So S13 square plus S13 square is equal to 1. That is about a twice of S13 square. So that by solving we'll get that S13 is equal to 1 by root. Now one more term we obtain here. So we can write here S13 will be a 1 by. Okay, so from this row 3 and a column 3. Sorry, row 3 and a column 3. Then a row 4 and a column 4. Then a row 4 and a column 4. If you consider that row 4 and a column 4, we'll get that S14 square plus square is equal to 1. So after solving this, we'll get that S14 is equal to 1 by root 2. We'll rewrite here S14 is equal to 1 by root 2. Okay, now S14 is equal to 1 by root 2. That is about we obtain here. Next, if you substitute these values in the first equation here that we are derived, that is about multiplying row and a column 1, row 1 and a column 1, this equation multiplying row 1 and a column 1, if you substitute that value of all these we obtain here, so that equation is, I am going to rewrite the equation again here. Okay, that is a row 1 and a column 1 equations I supposed to be rewrite here. 1 1 square plus s1 2 square plus s1 3 square plus square equal to 1. Now s13 and s14 values. S14 is what? 1 by root 2. S13 is 1 by root 2. And S11 we know that it is about S22. So if you put that all the values here, so we'll get that S11 square plus S12 square, okay, plus 1 by 2 plus 1 by 2 is equal to 1. Now from this 1 by 2 this 1, okay, then 1 goes here. We'll get that S11 square plus S12 square. Now this one S11 square plus S12 is equal square is equal to 0. So now this will be valid if this equation is valid if S11 is equal to S12 is equal to 0. That is about the valid condition. And then we say that here earlier from equation we say that S11 is equal to S22. We can say that from the equation earlier we say that S11 is equal to S22 here. And then this is about the a valid conditions for this S12 is equal to 0. So from that, if you consider the equation again, okay, so that is about our equation again. If you consider that if we use this equation again here, so from that equation we'll get that S11 is equal to S12 is equal to 0. So earlier say that S11 is equal to S22, so S22 will be equal to 0. Okay, that we are getting. So now what we are getting here, S11 is equal to 0, S22 is equal to 0 we are getting. Okay, and then we are getting that S12 is equal to 0, that we are getting. And similarly using the property of a symmetry S21 is equal to 0. So now if you put all the values in the S matrix here, all the matrix, all the values in the S matrix, so now these terms are 0. As I told you earlier, we can prove it again. So this will be a 0, this will be 0. These two terms are a 0 as I told you earlier. Now the term whichever the S13 and S14, S13, S14, S13 is what? It is about 1 by root 2, S14 is a 1 by root 2. So from this we will write the S matrix for this magic T here. I'll just, it is equal to what? 0. This one is 0. S13 is equal to what? We say that it is about a 1 by root 2. It will be a 1 by root 2. This one is again a 1 by root 2 here. Then S13, 1 by root 2. Here minus 1 by root 2. 0, 0. 1 by root 2 here. 1 by root 2 here. Okay. And then this is about a minus. We can say that, sorry, I just forgot one term here. Okay. This one is about a 0, 0, 1 by root 2 here. Then this one is about a 0, this one is about a 0. Minus 1 by root 2 here. Then 1 by root 2 here. Okay. So then 1 by root 2 minus 1 by root 2, 0, 0, 1 by root 2, 1 by root 2, 1 by root 2. Okay, so now this is about your S matrix for the magic T. Now this one, if you see the matrix here, so it has a common of 1 by root 2, 1 by root 2. If you take out the common 1 by root 2 here from this given matrix, so we will rewrite the matrix again. So it will be what? Common is about 1 by root 2. We'll have a matrix here that is 0, 0, 1, 1. Okay. Then it is about what you can say that 0, 0, minus 1, 1. Then 1, minus 1, 0, 0. Then 1, 1, 0. Now this one is about a matrix. This one is a minus here. This one is a minus. Only these two terms are a minus here. And this one is about S matrix for the magic T. Okay. This one is about S matrix for the magic T. We are getting all the terms are 1, 1 here. We take a common 1 by root. That's all about your S matrix for the magic T. Now then we talk about that what are the applications of a magic T here. Okay. Or we can say that applications of a EHT, or we can say that that is what are the various applications here. EHT, or we can say that a magic T. What are the various applications? Magic T can be used in various applications. We can say that first we say that a EH tuner. We can use a magic T in a EH tuner. Then we can use magic T in a balanced mixer. We can use a magic T as an isolator here. We can use a magic T as a phase shifter. We can use the magic T as a switch, transmitter, receiver switch in a transmitter receiver. Okay, so now how this tuner is to be used. So we know that EH tuner means what? We need to apply a variable short in a arm, E arm and a H arm there. We have the E arm and H arm. We need to apply the variable short to this E arm there. Then that E arm and H arm will be act as a stub there. And then position of that particular short is to be adjusted so that we'll get that whichever the load impedance we require. And then that will be required. That will reduce the VSWR. So that is about the rule of the magic T as a EST. Then a balanced mixer there. So in the balanced mixer, we know that it has a 4-port one. 4-port means what? Your main arm, we say that a port 1 and a port 2 now. 1 and a 2. This one is about a port 3, that is about a E arm we say. And this one is about a H arm now. Now if you consider that, if we apply or you use a mixer at a port 3 and at a port 4, that is H, okay, H arm, if we use a local oscillator here, and this one is about a matched one, this one is a matched port, and here we supposed to be consider that a IF amplifier. Okay, this one is supposed to be considered that a IF amplifier. So this one is to be used as a balanced mixer. So this one is about a mixer. We can provide the signal through this. So that signal through this, what we consider that a antenna, through the antenna we provide the signal. Okay. Next is about, we can consider that is the same as the duplexer there. Or you can say that a transmitter switch or a balance isolator means what? Because these ports are isolated here. That's why I can say that isolator. One of the port is to be considered, okay, to provide a feeding technique or a double power feed power here. Then we can consider this one is to be act act as a phase shifter also. Okay, so we can change the length of this arm and all. So duplexer, we supposed to say that it is transmitter switch. In that case, we supposed to be consider that a port 1 antenna here, then transmitter at a E arm, then we supposed to be consider that receiver at a H arm, and port 2 is to be a perfectly matched termination. So then this one will be used as a duplexer or a transmitter switch. So that's all about a magic tree and their applications. So we can use the magic tree for various applications there. Okay, so that applications we see that tuner, mixer, oscillator, phase shifter, and a transmitter. That's all about magic tree. Thank you all of